Hello, my name is Dylan Abrukta, and I'm representing the Chemical Engineering Capstone Team number 4 for the year 2022 to talk about the Brain Microdialysis Project. The motivation taken for the Brain Microdialysis Project is to improve on the current treatment methods for delivery into the brain using microfluidic delivery systems. An additional motivation is to reduce the requirement for animal cadavers, animal testing, as well as potential human testing during the development of neuromedical devices and for experimentation. Because of this motivation, the objective of our capstone team is to establish new methods for analyzing microdialysis drug diffusion in a synthetically developed brain, to create an economical, efficient, and recreatable procedure for developing microdialysis probes, to optimize slicing and imaging techniques for the synthetic brain model, to design streamlined techniques for retrieving data, and to provide data utilizing a synthetic brain model rather than that of an animal brain model. One question that is commonly asked is why use microdialysis for injecting medicines and drugs into the brain over common needles, and the main reason for this is typical injections leave inflammation caused by the fast injection rates entering the body and the natural response to foreign bodies. This may be fine for injections to the skin. However, for the brain, where the natural response can cause damage to other functioning regions of the brain, making use of this typical injection method is not preferred. Therefore, microdialysis is used to create a less invasive treatment method and improve patient care. Microdialysis works similar to dialysis by using the difference of concentration, in which regions of higher concentration pass to an area of lower concentration, to transport fluid-based medicines into the brain and/or other parts of the human body. The results of this effect can be visualized in the video represented below, where microdialysis is used to inject the modeled synthetic brain, resulting in the darker hue forming over a period of 6 hours. The method for this is typically used for sampling and quantifying a multitude of functions within the body. Finally, once the diffusion is performed, the data is gathered by making precise slices of the synthetic modeled brain and gathering the diffusion data across each slice using custom-designed imaging software, which is then used to establish parameters to determine the diffusion using 3D rendering software. The future of this process and microdialysis is to therefore be used for neurointensive care monitoring, to create standards for measuring drug diffusion, and to create accurate modeling software to predict the diffusion and effects of different types of medication in the human brain. Thank you so much for your time.